Hello, Matthews Gatos here. Welcome to your first video for limits of trigonometric functions. In this video, I'm just going to introduce you to trig functions and their limits. So think back to 30-1, sine of theta. Here's the graph of sine of theta, just one cycle of it. So I want to look at the limit as theta approaches 0 from the left and the right of sine theta to see what the limit of theta as it approaches 0 of sine is. So as I approach it from the left, I get closer and closer and closer to 0. You can see I approach 0. Let's look on the other side as I approach 0 from the right. So I'm getting closer and closer and closer on the right, and I also approach 0. So since the left-hand limit and the right-hand limit are equal, the limit as theta approaches 0 of sine is just 0. Let's look at cosine graph. So cosine graph, here it is, starting at a high, going down in both directions, one cycle of it. I want to look at the limit as theta approaches 0 from the left and the right. So from the left, what happens as I come in from the left? I come in closer and closer and closer to 0, and it looks like I'm going to 1. So let's look from the other side. From the other side, approaching cosine, on the cosine graph, approaching 0 from the right. Coming in closer and closer and closer to 0, I also approach a value of 1. So since the left-hand and right-hand side are equal, the limit as theta approaches 0 of cosine is just equal to 1. And let's look at our tan graph. So our tan graph here, we're going to look at the limit as it approaches 0 from the left and the right. So for tan here, as I'm coming to 0 from the left, I'm getting closer and closer to 0. It looks like my function's going to 0. Look at it from the right. As it comes in from the right, getting closer and closer to 0, it also looks like it's going towards 0. So for both of these, I can write 0 since the left-hand limit equals the right-hand limit. The limit as theta approaches 0 of tan is just 0. Okay, now of course you can look at limits graphically, but if you can sub the limiting value in, you should always sub it in. So let's just evaluate these again just by subbing our limiting value in, because we're not doing any division by 0 in any of these cases. So we can just sub it in. To sub it in, I'm going to remind you that the point 0 on the unit circle has coordinates of 1 and 0. So I know that this one here is cosine, and this one here is sine. So cosine is equal to 1, which we saw in the graph. Sine is equal to 0, which we also saw in the graph. And tangent is sine divided by cosine. So 0 divided by 1 is 0. So it looks like it checks out by subbing in the limiting values. Now, if I know those trig limits, then I also know their reciprocal trig functions. So I would also know cosecant, secant, and cotan. So since the limit as theta approaches 0 of sine was 0, if you flip for cosecant, that would be 1 over 0, which of course we can't do, so that limit does not exist. Let's verify that graphically. So looking at this graphically, as I'm approaching 0 from the left, I'm getting closer into 0. It looks like I'm going down towards negative infinity. And here as I get closer into 0 from the right, I'm going up towards positive infinity. So since they are not approaching the same value from the left and the right, the limit does not exist. Okay, let's look at cosine. We said the limit as theta approaches 0 of cosine was 1. So if I take the reciprocal of 1, that's still 1. So it looks like the limit as theta approaches 0 of secant would equal 1. So let's verify that. As I approach 0 from the left-hand side, I get closer and closer and closer to what appears 1. And from the right, I also get closer and closer to what appears 1. So it looks like that checks out. Let's look at tangent. So the limit as theta approaches 0 of tangent, we discovered was 0. And so if I flip 0, take the reciprocal of 0 for cotan, it should be that that limit does not exist. So let's verify that graphically. So here is my graph for cotan, and I want to look at the limit as this approaches 0 from the left and the right. So approaching it from the left, you can see as I get closer and closer and closer to 0, I go towards negative infinity. And on the right, as I approach 0, getting closer and closer from the right, I also go to a negative infinity. So since the left-hand side doesn't equal the right-hand side, that limit does not exist. Okay, so let's look at some quotient limits. So let's look at this one here. The function y equals sine theta over theta. And I want to look at that graphically first, and you can see I have the table of values to help us as well. So as I approach 0, I'm going to look at the limit as theta approaches 0 of this function. So as I get closer and closer and closer to 0 from the left-hand side, you can see I'm coming into a value of 1. And as I get closer and closer from the right-hand side, I come in and I'm getting closer and closer to a value of 1. I'm going up by 0.5s there. So it looks like the limit as theta approaches 0 of sine theta over theta is 1. Let's look at the table of values that I have. So you can see as I approach 0 from the left-hand side over here, I'm getting closer and closer and closer to 1. On the table of values on this side, as I approach 0 from the right-hand side, I'm also getting closer and closer and closer to 1. So I can say with good authority that this is equal to 1. Now, what if I took the reciprocal of that? If I wanted to look at the limit as theta approaches 0 of theta over sine. Well, if it's true for sine theta over theta, I would just have to take the reciprocal for this one here, and the reciprocal of 1, of course, is just 1. So I want to do the same thing now for tangent. So look at this graph here. We have tangent x over x, and I want to know the limit as theta approaches 0 of tan theta over theta, and of course the reciprocal as well. So if I look at the graph here, as I approach 0 from the left-hand side, you can see I'm getting closer and closer to 0. My function is getting closer to 1. And look from the right, as I get closer and closer and closer, I also approach 1. Well, we can verify that in our table as well. So as I get closer to an x value, starting here at -1, getting closer to an x value of 0, my function goes towards 1. On this one here, as I get closer and closer to 0 from the right, my function value gets closer and closer to 1 as well. So we can say the limit as theta approaches 0 of tan theta over theta is 1, and the reciprocal of 1 is also 1. Okay, I just want to do one more tie up here, and then we're going to look at cosine. So the ones that we just did, this is something you can memorize and use in future questions. So we've seen now the limit as theta approaches 0 of sine theta over theta is 1, or the reciprocal of that. The limit as theta approaches 0 of tan theta over theta is 1. So we can memorize this and use it in the future. I want you to make note that these all have to match. All of them have to match. They all have to be thetas. Okay, so let's look at cosine and see what happens there. So here's the graph of cos theta over theta, and I'm going to look at this graphically and again in my table of values. So the limit as theta approaches 0 from the left of this function. So I'm getting closer and closer to an x value of 0, and you can see my function is going down towards negative infinity. On the right-hand side, you can see as x gets closer and closer to 0 on the right-hand side, I'm going towards positive infinity. Let's verify that in the table. So here's 0, so I'm going to approach it from the left. I'm getting closer and closer to 0 from the left, and you can see, look what's happening with my y values. They're getting bigger and bigger in the negative direction. On the table of values over here, as I approach 0 from the right, you can see I'm getting closer and closer to 0, and my y values are getting bigger and bigger in the positive direction. So since the left-hand limit does not equal to the right-hand limit, I can say that this limit does not exist. So this isn't one that we can use, but we can use the sine and tan one. And speaking of tan, it was out at the beach and quite embarrassed that its tan lines were showing. So I hope that this video helped. This is just an introduction to trig limits, and you can join me for the next one in which we'll put this to use with some specific questions. Okay.